This is a video for the answers or solution for the day 2 problems in your packet, 10 through 15. Let's do these problems. I'll try to write as neat as I can with my stylus, but it's not always the easiest. So here we go. Number 10. Lareina understands factors, so we know what factors are. Numbers multiplied to get a product. Sometimes she has trouble finding all the factors of a number. What advice would you give Lareina to help her find them? Demonstrate by finding all the factors of 100. Okay, so if you have a number like 100, my advice to you would be first notice what the last digit ends in. And in this case, it's a 0, so we know it's an even number. That will help you further down the line here. Even means it's going to be divisible by 2, and I'll tell you what that means. So if we start off with 100, let's first say any number has a factor pair of 1 times itself. So we've got 2 of the factors already, 1 and 100. Now because the number 100 ends in a 0, it means it's an even number. So we can take that number and divide it in half or chop it in half. So that means 2. So we know 2 times what would give us 100. Well, if we wanted to find how many 2's went into 100, we could do that. 100 divided by 2 is 50. I'm kind of going fast here just for time's sake. So 50 times 2, that means 2 and 50 are both factors. So 2 and 50. All right, so we've got 4. Let's go. We've got 4 factors. We've got 1, 100, 2, 50. How about 3? Well, 3 doesn't go into 100 because it's an even number, ends in 0. How about 4? Well, let's say 4. Well, if 2 goes into 4, 2 is a divisor of 4. 2 times 2 is 4. Then there's a good chance that 4 will also be a factor of 100. So 4 times what? Well, up here, I'm going to kind of write up here. So 100 divided by 4. Think about money. If you have 100 or $1 and you had to chop it up into 4 equal parts, that means each person should get what? 4 goes into 10 2 times. 4 times 2 is 8. 10 minus 8 is 2. Drop down to 0. 4 goes into 20 5 times. So 25. So 4 times 25. 5. Well, 5 times 2 is 10. So that means 5 probably goes into 100. So 5 times, over here I'm going to do the 100 divided by 5. 5 goes into 10 2 times for 10. 5 does not go into 0. So 5 times 20 gives us 100. So 5 times 20. 6, 7, 8, 9, 10. Well, 10. I'm going to underline, these are important numbers. So 5 times 2 is 10. So that means 10 is most likely going to be a factor or divisor of 100. So 10 times what gives us 100? Well, if you don't know, do the division. Again, that's why we need to know long division. 10 goes into 10 one time. 10 does not go into 0. No remainder. 10 times 10 is 100. All right, so the factors of 100 are 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. And that looks pretty good. Let's move to the next problem. Suppose you circle a prime number on the factor game. Your opponent receives at most 1 point. Explain why. Use examples. Well, if you choose a prime number on the factor game, I'm going to shrink this down a little bit so we have a factor game down here. If you choose a prime, remember, is a number that only has 2. So a prime has 2 factors. This is not the answer, I'm just reviewing. 2 factors, 1 and itself. Okay, that's important to remember. So any of the numbers down here, and remember in class we did that group. So any of these numbers are prime numbers. I'm going to crank through and get the primes here. I'm going to get the primes. I think I've got them all. Okay, so those are the primes, and it says your opponent gets 1 point when they choose a prime. I'm going to erase this now. So suppose you circle one of the primes below. Your opponent receives 1 point. Explain why. The only reason they get 1 point is because a prime number only has 1 in itself as factors. So let's use the number 19. Actually, let's use 29 because 29 was the coolest one on the board to get the most points. There's only one way you can make 29 with a factor pair. 1 times 29. So you would get 29 and they would only get 1. Okay? Erase this. Let's go to the next problem. Number 12. Suppose you circle a composite number on the factor game. Your opponent might receive more points than you. Explain why. Use examples. Well, let's use the one we used in class. They would get more points on certain numbers. If your opponent chose, if I choose 30, Mr. Kruger would get 30. What would you get? You would get 1, 2, 3, 5, 6, 10, 15. I get them all? I believe so. So if you add all those up, so I would get 30 and you would get 1 plus 2 plus 3 plus 5 plus 6 plus 10 plus 15. So how many points would that be? So if you add up all of these numbers right here, you would get 42. So that would be a situation where I chose 30, which is a composite number. You got all the factors, the proper factors, to equal 42. All right, I'm going to erase this board. Let's keep moving. 13. The factor game can be played on a 49 board like the one below. In class, we only went up to 30. Remember, we just went up to 30. So we used all the numbers through 30, and obviously it was a square. The board looked like more of a square. So this one says, if you went on a 49 game board all the way up to 49, what new primes can you find? Well, what new numbers are primes? What new numbers are prime? Well, 31 would be prime. Why? Because 31, the only factor pairs are 1 and 31. Let's see. What other ones are prime? Looks like 37 would be prime. Oops, I wanted my highlighter there. So 37 would be prime. 41 would be prime. 43 would be prime, and 47 would be prime. Those numbers only have 1 and themselves for factors. What new square numbers? So square numbers are numbers, they're cool numbers. They're numbers that make a square. So let me show you what that means. What new square numbers? That means any number times itself. So a square would be like 1 times 1 gives me 1. It makes a square, any number times itself. So 2 times 2 would give me 4. So square numbers make squares. So any number times itself. So what numbers there would be square numbers? Well, let's use green. 7 times 7 is 49. Is there any more square numbers? 6 times 6 is 36. And that's it. So there would be 36 and, I like black better, and 49. And the new primes were 31, 37, 41, 43, and 47. Moving along. Long ago, people decided to divide the day into units called hours. They chose 24 as the number of hours in one day. Why is 24 a... Pause this video. I cut part of mine off. So the question is, why is 24 more convenient to use than 23 and 25? So why is 24 more convenient than 23 or 25? Well, 24 is more convenient because it has more factors. More numbers can divide 24 up evenly. Let's do the factors of 23. They're 1 and 23, so there's only 2 factors. Let's do the factors of 25. 1 and 25, 5 and 5, so there's 3 factors. 23 only had 2. And then 24 has a bunch of factors. Let's do this one in green. So we can say 1 times 24, 2 times 12, 3 times 8, 4 times 6. Did I get them all? 1, 2, 3, 4, 5, 6, 8, 12. So this has 1, 2, 3, 4, 5, 6, 7, 8. 8 factors. So that's why that's why we use 24. There's more divisors that go into 24. It's easier to divide up 24. I don't know if that's exactly the reason why they use 24. We could look further into that. Okay, so those are the solutions for day 2 problems 10 through 15, I believe. I'm going to go like this. I'm going to move these out of the way. And I have one more to do for you. I have not forgotten it. It's number 15, and it's hiding down here. Why is 60 minutes in 1 hour better than 59 or 61? 60 minutes is better because it has more factors. It can be divided up in more ways. 59 and 61 are both prime. These two cool cats are both prime numbers. And 60 is a composite number, and it has many different factors. 1 in 60, 2 in 30, 3 in 10. Let's see here. Excuse me. 4 and 15. Did we get them all? 5. Should we see if... Oh, let's just make sure. 65. 5 goes into 6 one time for 5. Oh, 12 and 5. Almost forgot 12 and 5. So even I missed some of them. 6. 6 goes in there 10 times. So 6 times 10. 7, 8, 9, 10. There it is. I think we've got them all. So we use 60 minutes instead of 59 or 61 because there's many more factors. How many factors are there? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of them. 12 of them. And those factors are also called divisors. All of these are also divisors. That means you can take 60 divided by any of these numbers and you'll have no remainder. So it was a very long video. Just fast forward to the parts you need.